Welcome back to my 3-part series on this 12-volt Canopy fit out. In the last video, we went and unboxed a few parts and set out a plan for this fit out. Now, in this video, we're going to be going in detail from start to finish. This will include the whole process of fitting out the front wall of the canopy, all the wiring, all the connections, fitting the fridge, the lights. So there's going to be a lot going on. Make sure you use the timestamps. Now, as a disclaimer, I am not qualified to do any of this, nor am I qualified to teach you anything. Electricity is dangerous, and although it's just 12 volts, it can still do a bit of damage. This is all for fun, but I am bloody good at 12 volt. Let's go blow something up. Okay, we're gonna start by fitting out the front wall of the canopy. This is the front panel on the passenger side, and on the driver's side, we have a smaller panel. In this area, we're going to be housing a Bushman upright. It is about 550 in depth, and giving it a bit more for clearance. Let's just say 600. From here onwards, on this side of the panel, we're probably not going to have good access, but that's going to be okay. I'm going to be mounting the red arc inverter there, which is remotely controlled, and also the Manager 30 charger, which is going to sit nicely here. The AC port on the Manager 30 also sits here, which is going to be easy if I need to just plug it in for an overnight charge, which leaves us a bit more access on this corner. And I'm going to be mounting the Red Vision screen here, a few USB outlets, an Anderson plug, and our circuit breakers for troubleshooting. That's the passenger side. Now, the driver's side front panel is all about access for troubleshooting and charging. Now, at some point, a fuse is going to blow, and we want to have good access so that we're back on the road quickly. I'm going to be installing our TVMS system right over here. So the TVMS houses all our fuses, got the manual override switches, and also a few spare fuses. I've got it right over here. So all in this little access hatch, there's everything you need to do some troubleshooting. We're going to be mounting it right here, which leaves us a lot more space. We're going to be fitting a double power point, 12 volt outlets, our Anderson plug, and our second Red Vision screen. So yeah, I'm going to make life easier by pulling the panels off, and we're going to go work on the bench. At this point in the video, we've just surpassed 5,000 subscribers, so a huge thanks to you guys for all the support. To celebrate that, my website's just gone live, and you can go check it out, learn a bit more about the channel, and also we've released these new Pit Crew shirts in honor of you guys for supporting the channel. They come in adult sizes in both the white and the gray. We've also got an unlimited run of junior shirts. We've also got infant tees. They also fit the cats. Make sure you go and check it out, and I hope you guys enjoy the video. So everything fits really well as per my plan. I've rearranged just a few little things, but yeah, it's working out well. Anyways, let's drill some holes. All right, so the Red Vision screen, there are two ways to mount this screen. The stealthiest way is actually just to do a big cutout and then mount it straight onto the panel with the through the 4 holes. But the way I'm going to do it, and it's because really I don't want to do a big cutout here, is to mount it onto this base plate. Now with the base plate, it means that I only have to do a little cutout for my 2 CAN bus terminals. If you go to the manual, it actually has a little template at the back of the manual that you can use. Bit of arts and crafts. Bullseye. $28mm. So just on the spot, I've decided I'm going to run both the USB ones on the bottom, just like that. And literally a minute ago, I realized that I could just have removed the panel completely and just mounted it straight onto the panel. And I could have just run them in a straight line. And the Anderson plug. So the way I'm mounting it is through these 2 holes, and I'll drill 2 additional holes here for the positive and negative cable. I'm using a little screw to help me mark it out. So this is going to be limited to 30 amps, and let me see if I got some cabling right here, but yeah, we're going to get away with something like this. Just 2 more holes for the cable. All right, so this is the last we're going to be doing on the passenger side panel. And yeah, just these 3 circuit breakers and this panel will be ready to go for paint. Now, these 3 circuit breakers, they're in no particular order at the moment, but they have the same physical dimensions. We need to make a cutout of 40 by 50. So just draw a straight edge. We're going to line these up, and we're going to do some cutting, and it should be right about done. All right, killed it. Look how nice those edges are. Just kidding. I know that I've completely just hacked it up. I've stuffed up, but I have just literally found this product. I know they exist, but I didn't know that there was going to be one for my circuit breaker. This is a panel mount adapter. It's a bit of rubber, and just so happens that these dimensions are exactly the same as my Volta one. So yeah, I've been kind of saved by that because these edges aren't looking very shabby at all. So I'm going to order those, and then it's going to hide those beautiful edges. All right, so what's left to do is to remount everything. So this passenger panel is ready to go, but I just want to make sure everything fits in the canopy as well. So I'm going to put it all together, and then we're going to fit it up. Here is the front panel on the passenger side. It's pretty heavy, but I like it. And yeah, it looks really good as well. Let's get it in. How good has it turned out? Good, but not perfect, because got a little gap at the top there. The 2 top bolts are just nicking the rail, so the frame rail. It's not a big problem. I think what I'll do is re-drill one of the holes a bit lower, 2 of the holes a bit lower, and I think it should fit just fine. Good excuse to use this. Over there. Okay. So it's about half a bolt space lower, and we should be all right. It's getting there. It's also getting pretty late. So I think this is going to be a job for another day. Yeah, shouldn't take too much longer. Maybe another week, and then we can get this sent off for paint. All right, so this is the drive side panel, and it is pretty much done. You'll notice the difference on this side is that it has the TV mesh unit, and of course I'm going to try to hide all the wiring behind the panel. So I still need to drill a few holes here, but we'll work that out a bit later, I think. You would have seen that I cut some nice edges again. That's about it. I am going to strip everything off these panels, and we're going to hand it over to the master painter, Chris. While the panels are off for paint, this is a good opportunity to do a quick tutorial for those who are new to 12-volt wiring. And we're going to be starting by powering this light. This is the Steady C4 spotlight. It's just what I had laying around. It's not for the canopy, but we're going to be using it for the demonstration. So to power this light, all we need to do is to connect the positive cable to the positive side of the battery and the black negative cable to the negative side of the battery. So I'm going to quickly do that. So this is it's a very bright light. What we have here, we have a very basic 12-volt circuit. We have the load, which is the steady light. We have the conductor, which is the cable. And we have the power source, which is this standard lead acid battery. Now, how you choose the battery and the cable really depends on the load, which is the steady light here. So if you go to the spec sheet of the light, you'll find that this light will draw 2.1 amps. So you want to choose cable, twin coil cable rated to 2.1 amps and above. Generally speaking, I usually just allow another 10-20% on top of the rated amps just to be safe. So yeah, same goes to whatever accessory you are needing to power, you need to find out the maximum draw of your load. For example, I know that this LED strip, which is going on the canopy door, is rated to 1.2 amps because it says here on the packaging. I know the fridge will draw approximately 4.5 amps. And I know that this Red Arc 2000 watt inverter can draw upwards of 200 amps. So for each connection you make in a 12 volt system, you'll really need to figure out what size cable is suitable for each application. And for selecting a battery, your power source, there's a bit more to consider. But as a guide, you want to work out your total amp draw. So it could be the total amp draw of just the one light, it could be multiple lights, it could be a light, a fridge, a compressor. You want to work out the total amp draw and how long you want to power that device for. Let's just say we have a standard 100 amp hour lithium battery and we're just powering this device, which draws 2 amps. You will be able to power this for roughly 50 hours before completely depleting that lithium battery. We're strictly talking lithium here. It's a different story with lead acid and AGM batteries. In almost all cases, this type of circuit is going to have a fuse. Sometimes you might have a mini fuse, you might have a standard blade fuse, you might have a relay, you might even have a switch to power it on and off. Could be a momentary switch. Sometimes you might even have a circuit breaker. Now when sizing the fuse, you want the fuse to protect the load. So obviously we want to protect the steady light. And if you've given yourself that 10-20% sealing on the cable, the fuse will protect the cable just the same. So coming back to our 12 volt system, this is where the TVMS comes in. This is the beauty of the TVMS. So for my setup, it will handle the fuses, the relays, and the switching all in one central system that I'll be able to monitor through that Red Vision screen. So yeah, hope some of that made sense. Let's put that into practice. We are moving on to the lighting installation of this fit out. And in part 1 of this series, I mentioned that I wanted to keep the lighting very basic and simple. The reason is because just generally speaking, when I'm camping, I don't have a whole lot of synthetic, I don't know the word. I don't have a whole lot of lighting around. I usually have a fire and just a small LED strip on. So we're going to keep this quite basic, and also at the same time, the new awning I'm putting on has built-in LEDs into the frame. So that's going to be pretty cool. We're going to keep the canopy lighting very basic. So the plan is to install 2 1 meter LED strips, one on each canopy door, and also one big floodlight right over here. And I did mention in the video, the last video, that I was very torn as to what light I was going to choose, but I've gone with this steady 90 watt floodlight. It's quite a chunky one. It's going to be going right over here. I wanted to serve 2 functions. So the primary function is to flood everything behind the canopy. So it's going to be really good for the trailer. It's going to be good for unloading and loading the boat. And just generally flooding it's going to really shine behind the canopy. The second function is for it to be a little spotlight for the kitchen. So I generally cook in this area. I'm planning to make a little table which sits out over here for my little cooker. I want this light to provide a bit of lighting for the kitchen. So of course a 90 watt light is going to be way too bright, and I've been playing around with a few different dimmers. And this is the dimmer that we're going to be using. Now I tested this for about an hour yesterday and it was absolutely fine. I did ring Steady up as well, and they said it was okay to use a dimmer. It won't damage lights. So this is a PWM dimmer. I got this for 30 bucks off eBay, and we're probably going to mount it around here somewhere so I can adjust it as needed. Starting with a Steady light, we're going to be mounting it under this wing, and the wiring is going to be going through a cable gland. So this one is an M16 cable gland. So an M16 gland needs a 16mm drill bit, which I don't have. So I'm going to drill a big hole, and then we're going to start burying it out. Snug fit, that's a good fit. So this is the wiring harness you get with the Steady Spotlight. It comes already pre-terminated with these Deutsch connectors. It makes it nice and easy. So just with these cable glands, you've got the top nut. Once you crank the nut down onto the gland itself, it actually forms another seal inside the gland. Definitely helps to keep the water out. So to thread this through the canopy, straight through that top nut, through the gland, onto the other side, and then just crank it down, and you've got a nice seal on the harness. There's the Steady light mounted in place, got the Deutsch connector into the black of that light through the cable gland. And then on this side, the wiring harness comes out. And we've got those two wires, the red and black. We're going to be installing the meter long LED strip right on the frame of this door. So just right like that, which means we're also going to have to drill a hole here to run the cabling all the way back to our 12-volt setup. This light bar also comes with a dimmer function, so it's got an on-off switch. It's got the different modes and also the brightness. So you can see that Norwell have already pre-cut these two holes there for the dimmer switch, I believe. So this goes on like that. The cabling tucks up inside, like so. So it's gonna sit like that. LED light bar here, the wiring goes through this hole. The cabling runs to the dimmer side of this switch. And from this end, the power cable through the door frame to our 12-volt setup. We're gonna be using this body tape to stick our LED strip onto the door frame. Now, when you're running cable, sometimes you don't have great access, and in my case, I'm trying to run a piece of wire from this hole here out the end of this frame to the 12-volt setup. And the access isn't great, I can't get my hands in there. Sometimes you might just be able to poke the cable through and miraculously just exit the other end, but there are better ways of doing it. Electricians, they have what's called a yellow tongue, which is a piece of reinforced plastic. They push and pull cable through walls and bricks, that kind of thing. Well, us pros, we have something even better. We have a coat hanger. Now this is a metal coat hanger which I've straightened out. The beauty of these types of coat hangers is that it's metal, so that when you contort them, it's got memory, so it keeps its shape. And you're able to run wiring around different things, and it's a lot easier than just guessing and just hoping for the best. So we're gonna demonstrate this with the cable. Put my wire over here, I'm gonna put some electrical tape around it just to hold it in place. Just like that, and we're gonna stick it through the hole. Alrighty, how good does that look? I've just got the LED strip hooked up to the test battery just to see the light output, and it looks really good. You've got a mode button here, so you can control the color light. So this is an amber light, you've got a warm white, which is kind of like a mix of the both, and a cool white light. On and off, and you've got dimming all the way down full bright. So yeah, something I want to show you guys is it's all the little finer details which make a 12-volt setup reliable. You know, always making sure the wiring is protected, because all those little details are what's going to make or break the system. So I generally carry just a few grommet kits at home. You can kind of see which ones I use more often. But yeah, those are the things which will make your 12-volt setup reliable. We are up to the final lighting circuit. So this cable is going to be going to the awning lights, so the built-in LEDs on the awning. And I've been really pondering what kind of connector I want to use here. So I did think about maybe like a stainless steel flush mounted barrel connector. Thought about a Deutsch plug, but I've decided to go back to the old faithful 50 amp Anderson plug. And the main reason is for just how universal these are. If I ever wanted to plug anything else in which is under 10 amps, I will do that through this plug. So I'll be flush mounting it right over here. Because this is a 50 amp plug, this is the standard contact you get. So this is an Anderson contact rated to 50 amps, and you can see it's quite a large internal diameter for some large cable. And if you buy these contacts, it's a thicker wall with a smaller internal diameter inside the contact, so you can fit smaller cable. All right, so when preparing these contacts, the age-old question, should you crimp or should you solder? I believe that people can probably crimp better than they can solder. Personally, I don't have a preference, and I do both. It just depends on the application, the access, and I guess what kind of mood I'm in. However, I will say that I have had a crimp connection fail due to no fault of my own. It was actually for a high amperage application. It was a King's air compressor, and the contact had become loose from the wiring and ended up melting that Anderson plug. So something that I learned along the way is having the right tools. So I've ended up using a crimper like this more recently, and it hasn't failed me since. So this is just a cheap crimping tool from eBay. So yeah, we are going to crimp this connection. Okay, so with Anderson plugs, I have covered these before. There's a positive and negative side, and there's an orientation to which the terminal sits inside that locking tab, the metal locking tab inside the connector. So it sits with a hump on top like that. So when you are crimping this down, you're going to be mindful which side you crimp the positive on. So that's the crimp. It's very neat. Pull test, all good. That's ready to go into the Anderson plug. Got the positive on the right side, negative on the left side. You got the Anderson contact, the bump sits on top, and it's ready to go into the connector. Push it in and click. There we go. That's it. That's the Anderson plug. So I've got all 4 circuits wired in, got the dimmer switch in, the Anderson plugs in as well, and I've just really taken the time out to try to make the wiring as neat as possible. So I've just been running all this conduit as straight as possible along the frame, using all these little cable tie mounts just to make it that little bit neater. And I've run this all the way to the other side, so it meets up with the driver's side LED, and it's all connected up. And something I want to show you guys, I got this, it's called a conduit hinged T. It really just makes the install a lot neater. And this conduit is all lighting, it's going to run straight to the TVMS. So I guess now we're ready to wire up those 2 panels. And conveniently, a huge thanks to Chris from CGI Panel and Paint. He's got these back to me, and I wasted no time in fitting it all back up ready for the wiring. It just looks so clean, looks good. I was told it was going to be too much sandy, but I don't think you can really have too much sandy. And something you will save a lot of money on is all the little bits and pieces. So I did a bulk order on stainless. Now this is just some of the stainless I've been accumulating, but making sure it's all ready to go once you get onto the wiring and the fit out. It'll save you a lot of headache, and it'll save you a bit of money too. So yeah, we're going to leave this for now. I actually want to clear up some bench space, so we're going to actually go and install that battery into the Canopy. When deciding where to mount your battery, ideally you want to have short cable lengths as close to the 12 volt setup as possible, with the battery mounted in a cool location. So in the normal Canopy at the moment, we're behind the drawer. There's actually a battery compartment with an access hatch on top to keep everything hidden out of sight. I'll pop this up. This is where my battery is going to live. This is a back breaker, this one. So the battery is secure, and the way I did this was by drilling through the canopy floor. So there's the canopy floor which sits on top of a frame, which is on top of the canopy base. So I'm really not expecting there to be any water ingress, but I also added some rubber sealing washers in there. So I've got 2 eye bolts and just a strap I had laying around. So if I ever need to tension it as well, I can do that. But combined with that EVA foam which sits underneath this battery, it's really going to help with the vibrations, but also being anti-slip so that this battery has nowhere to slide on this aluminium. So yeah, pretty happy with how it's turned out. Now it's finally time to wire in our panels, and I'm not going to show you guys the step-by-step for each product. You really need to go back to the user manual for instructions on your cable sizing, your wiring schematic, your grounding, and that kind of important thing. What I will show you guys are all the little connections we make, the process of making the loom, and also the little things that I do to make it a reliable setup. The plan of attack is to do as much wiring as possible on the bench. We're going to start with the critical components, so probably the Manager 30, and then we can start wiring accessories on top of that. And at some point, we're going to have to move back to the canopy and then finalize the wiring there. So I think let's just get started with the wiring, and I'll cover what's important as we go. All right, so this is some of the wiring we've done tonight. So pretty much got the Manager 30 all wired in. It's all quite raw. I haven't done any cable management, and once we put it inside a loom or some conduit, it's going to look a lot better. So yeah, I got the battery output going to the TVMS. This is the DC charge going to the SATA battery, and this is going to be the solar input. And yeah, this cable is going to run to the TVMS, and on this side, these are the cables running. It's going to be running through a gland here on the Canopy wall of marks right there, and then an Anderson plug to the car. So yeah, this is going to be the core to our loom. And once we start adding accessories on top of that, the loom actually becomes quite heavy. So I'm supporting it with a piece of aluminium L bracket got from Bunnings. It starts off life like this, and then you just cut a few slots where the cable is going to be going. And I just use some pinch weld just to protect the cable there. Again, I'm going to stress the importance of organizing yourself on a spreadsheet before you go ahead and tackling this. The wiring part of it is actually quite easy to do. Before we go ahead and tidy this all up, these are probably the most commonly used terminals you will use in a 12-volt setup. So let's go and have a look at how to do one. How you prepare your connections can be the difference between an electrical fire and a good connection. So I'm going to demonstrate how I do this. Got a bit of cable here, got my ring terminal and a bit of heat shrink. When preparing the cable, you want to measure up how much insulation you're going to peel off the cable. So just remembering, when you're crimping this down into the cable, you only want to crimp it onto the copper. To strip that insulation off, you can use a Stanley knife. I like to use a cable cutter like this. I just give it a bit of gentle force and then just twist. Just like that. That's the exposed copper. You want to just tightly wrap the copper down so all the strands are uniform in the right direction, and then you just slot the crimp right over that. You should be able to see some of the copper through the terminal there, and you shouldn't have any insulation inside the crimp. I like to use these pliers. They're just a pair of electrical pliers I got from Bunnings many years ago, and they're still going strong. And I'm using that part of the pliers to make the crimp. So just lining the crimp inside the pliers, making sure you push the cable all the way through, and then just crimp that connection nice and tight. And that's what it looks like after the crimp. And we want to cover this exposed terminal. We're going to be using a little bit of heat shrink. So this is glue lined heat shrink. I get this from JCar or Element 14. That's how you prepare one of these ring terminals. We've got a good crimp, we've got a protected terminal, and that's ready to go onto your stud. All right, this is looking so much better. So what we are trying to achieve here is to package the loom in a way that the cables are firm and secure. You don't want it to be tight, you're not trying to stress out the insulation, but you want it to be free from any movement. So you don't want abrasion, you don't want it to rub through and short circuit on something. The way I'm able to achieve this is by using different sizes of split conduit. Some of this fleece tape, it's all over where it needs to be, and yeah, being careful with not using too many cable ties. I tend to try to reduce the amount of cable ties I use because it can look very messy. I even try to maintain the same direction on the cable ties as well. This is what it looks like on the other side. Now, a lot of these red arc terminals are the screw down style. I'm not usually a fan of it because they can work themselves loose. They screw down onto the live copper. So you really want to make sure these are nice and tight. If for whatever reason it works itself loose, you're going to have some resistance in the circuit. Yeah. Now, when designing these setups, you really want to make sure that if for whatever reason one of the panels need to come off, that it is serviceable. Now, I'm not designing this to be quick release, but if for whatever reason I need to pull this off one day, it can't come off with too much difficulty. So with these two panels being independent of each other, we can't have cables crossing without there being some sort of a connector in the middle. So we're using this Anderson plug here. I've got a few other connectors I will show you from the Deutsch range, just to make this a little easier to service in the future. We are going to be wiring in these NAV outlets. So we've got the accessory socket here, we've got 4 USB outlets here. And because of the space we're working with, we have about 50 to 60 mil clearance between this panel and the front wall of the canopy. Because of this, we can't use a standard style terminal. This is the standard spade terminal that you typically use on these types of connections. We're going to be using a right angled spade terminal, also known as a flag terminal. To crimp these properly, you'll need a special tool. These are insulated flag terminal pliers from Rhino Tools. Okay, got that knocked out pretty quickly. Got those 3 Nava outlets and the Anderson plug, and I'm running the loom underneath the L bracket this time. So it's going to the other side here. We've got these cables, got positive and negative of each circuit. Now, we're going to talk about the common ground point. The common ground point is a simple concept, but it's one which is done wrong a lot of the time. Having a common ground refers to the negative side of our 12-volt system, where you want to be sharing all the negative loads, such as from the battery to your charger to your 12-volt accessories, all continuous to a common ground. Now, it's worth mentioning because while it's quite a simple concept, it's easy to get it wrong like I have in the past. The easiest way to do this and the wrong way to do this is to ground everything to the chassis of your canopy or your vehicle. The canopy I have, well, canopies can be made of aluminium or steel. The chassis of a car is made of steel, they're both conductive metals. So while it will work as a grounding source, you're also increasing the likelihood of you short-circuiting something. Another reason you don't want to ground directly to your aluminium canopy is oxidization. So I've seen this a lot in the marine industry where they ground it directly to an aluminium hull. It's not the right thing to do, and with dissimilar metals and running a current through the aluminium, you're going to accelerate the oxidization and your paint's going to start peeling away. It's going to look really ugly. You don't want to ruin your boat. You don't want to ruin your canopy. So the best thing to do is to install a common grounding pole. So this is an OEX 250 amp ground terminal, and you want to have a ground terminal which will handle the entire amperage possible in your setup. So you can use a bus bar, just make sure you check the max amp rating. By having this ground, I can also run all my negatives from this panel directly to that grounding pole, which will also mean I won't have to run extra wires to like the TVMS. And from this grounding pole, one big thick battery strap to the negative side of the battery. So to utilize this ground, we're going to chop up these wires. So all those circuits will run the negative directly to this ground pole. And I'm only going to have the positives on each 4 of those cables to the TVMS. Again, I'm using one of these conduit hinge clamps. It's going to sit right over here, just like that. And then I've got my grounds running out to the pole, got my positives running to the Deutsch connector, which I will show you guys shortly. Okay, so I've got the 4 positive wires here, and I've decided to use the male DTP connector on this passenger side, and on the driver's side we'll have these female DTP connector with the mounting tab. So to crimp these, it's pretty straightforward with the right tools. You can get these in the open and the closed style crimp. So yeah, just going to prepare one of these and I'll show you guys how to insert it into the connector. Just strip this wire back. Sits in there like this. Not sure how you can see that. Sits in there like that. This middle crimp will crimp onto the copper, and this back crimp, the large crimp, will crimp onto the insulation. That's how I usually like to do this style of terminal. Passes the pull test. That is what it looks like. And then the back crimp. So this is the contact for the male connector, and this is my DTP connector from the back side. So you'll be able to see there's, I'm not sure if you can see, but there is a bit of a locking tab in there. So first of all, you're going to put your seal onto the cable. So this is the seal for the Deutsch connector. It makes it somewhat waterproof. It's not that waterproof. So insert the male contact into the back of the connector, and you'll be able to see that it comes through and sits nice and flush on the connector. It's not locked in place yet. You need to grab the Deutsch connector wedge. The wedge goes in like that. And then all you have to do is just push it down. that's locked in. That pin is locked in. And then just push the seal down onto that connector. And that's it. That's one of the wires on this two-way connector. I'm going to need to repeat this for the rest of these wires, and then we'll get back to you guys. I know it's been a long video so far, but we are really getting there. So yeah, this panel is 90% done. You'll notice that I've also added a third Deutsch connector, and yeah, my mistake. I forgot to add this circuit to the loom. So this is a cable which is going to be running into the back of the 79. So I've always wanted to have a 30 amp circuit going into the rear wall of the 79. Not that I'm going to do like a third battery, but I'm planning to have a little rear wall set up there. It'll supply constant power to like my dash cam, my internet modem, all the little things that I want to charge in the cabin off that secondary battery. So yeah, I added it into the loom, just another one on top. And I've also started planning the connections which are going to be coming out of the front wall. We'll get to that shortly. The red arc inverter is the last thing we need to wire in on this panel. And to power this inverter, it's actually quite easy. I can run a positive and negative straight to the battery, and this inverter will be ready to be used. For this install, I also want to utilize the remote function. So I'm going to run a comms cable from this side of the inverter to the TVMS for remote switching and automation and that kind of thing. So the power point sits over here, and I also want to add a DPO on the driver's side panel. So we're going to run a CMS lead with the connector over here so that that panel can be disconnectable and we can move the AC charging to that side of the canopy. Now, before I go and show you that, I want to talk about the use of fuses and circuit breakers. Personally, I've found that circuit breakers of this style haven't been very reliable past the 40 to 50 amps, especially when you're running them at the high ranges of the amp rating. Even in a recent video I did of an ARB air compressor install into my toolbox, I actually pulled out that circuit breaker which kept tripping and put a fuse in place. Now, fuses of all sizes I've found to be quite reliable, but the only downside is that you have to carry fuses with you, which isn't really a problem. So we're going to be running for the inverter an A&L fuse. So this is an A&L fuse holder with a 250 amp fuse in there. It's a very, very big fuse, but we're going to play it safe. We're going to run a big fuse and very thick cable, all rated to this inverter. Theoretically speaking, a 2000 watt inverter at 12 volts can possibly draw 200 amps under continuous load. So we're just going to play it safe, run a big fuse, run a big cable. The plan is to install this fuse holder right over here, so we have access from the driver's side. This is the cable we're going to be using. It's a 00 BNS. Now, if you think drugs are expensive, this stuff is like 50 bucks a meter. So yeah, a lot of copper. So same way to do this with a large ring terminal. You want to expose the copper, insert it inside the lug, grab your crimping tool, so this is the best I could get it to, and while I'm not completely happy with how I've run the cable, it's really the only way if I want to keep the fuse on this panel. And I'm okay with that because the clearance is still there. Still have 50mm between the front wall of the canopy and this panel. So the cable runs over this L bracket, got some extra heat shrink just to protect it there, and then into that hole through the other side to the A&L fuse. All I need to do now is to run a cable from that terminal to the battery, and that's it. So I was speaking to my electrician mate, and this is what he recommended. It's a CMS lead, and the idea is to make this a quick disconnect. So the plan is to cut one side of this cable, so we have the length from the power point on the side there through the back of the panel and have that connection. And he's also given me a side entry plug so that we can just wire that in very easily. I've had a lot of trouble with this plug last night, but I've got it knocked out today. So turns out this is a 20 amp CMS lead. Might be able to see right there. So the wiring is a bit thicker and I had to retrofit it into this standard 10 amp plug. I am not going to show that because I'm pretty sure it's illegal. It's not going to be a problem because this red arc inverter outputs 10 amps So this cable is going to be just fine. I think it's more of a problem if you work the other way around. Now we are going to piggyback this off an extension cable. So just pick this up from Bunnings. And we're going to run this outlet to the other side of the canopy. So to the passenger side, probably for my cooktop, and it's just going to piggyback on the back of it like this. There we go. The passenger panel is all done. What's left to do now is to prepare the front wall of the canopy to accept a few of these cables so that it can connect to the car, and then we can get this panel into the canopy. Feels really bad, but it's a necessary evil. All right, this is the first of 2 glands we've installed. So it comes out the side here. This will be going straight to the battery. We're gonna have another gland here, and then our Anderson plug, 2 Anderson plugs, one for the solar and one for the in-cab charging. So got the 2 glands mounted up, and now we're going to mount the Anderson plugs. So I saw this bracket on one of Norwell's vehicles, and I got to say, I love custom brackets because it just makes the whole setup a whole lot neater. So I reached out to Jono from Norwell Sydney, and he sent me out one of these. So it's even got solar etched in, got 12 volt aux as well. So of course I'm going to use this for the cabin. But rather than having the Anderson plug just flopping around back here, I'm going to mount it nice and securely on the back of the canopy. I had one of these cork gaskets laying around, so I just thought I'd make a little gasket just to waterproof it a little bit better. Got that bolted down. Let's get the panel on. This part's going to be pretty tricky because these panels are really heavy. All right, just going to start threading the cables through. Okay. I think the panel's ready to go up. How good has this turned out? I'm extremely happy. This is exactly what I had in mind. Now, what I'm trying to do and achieve here is to waterproof this gland as much as possible. So 90-degree one will be fine because the water's just going to run straight off it. But with these seals, sometimes you can get a little bit of water pass. When you tighten the ring, it will squeeze down on the cable, or in this case, the split conduit. But we're going to go that extra step and shrink some of this adhesive onto it. So what I've done here is push the conduit into the gland, and I've no doubt that if I was to tighten this ring onto the gland, it'd actually form a pretty good seal. But we just want to be sure, because right behind this is all the electrics. So the next step is just to feed all the wiring through this locking nut and then tightening it all the way down. I'm gonna get my adhesive and then wrap it all in right over the gland itself. Just working your way from the gland and slowly just bend it down, and it'll slowly conform. Just careful you don't melt the split conduit as well, because if you use a pretty poor quality conduit, it's going to melt it away. Perfect. 3 plugs here. I got one going to the starter battery. Took some time measuring the outlet where it's going to sit on the tray, so this should plug straight in. And then solar panel, which is on the roof of the 79, and the in-cab charging. We're going to get on to doing the driver's side panel. It's all over there. There's not much to do, to be honest. Most of this we've already covered, so I might just knock it out and then show you guys what I've done there. We're getting closer, guys. Tonight I've been in the passenger side of the canopy, just working out how we can manage the cable coming from the passenger side panel, the battery, and also the lighting circuits that we organized earlier. So unlike the passenger side panel, now all the wires are coming to this side and terminating into the TVMS. So it's a little bit different in terms of the method of wiring, but we're still going to try to be systematic. We're going to start with the core wiring and then start adding circuits on top of that. So this is what I've come up with so far. The objective is just to keep this kind of clutter-free and also easily serviceable. So this should make a bit more sense, and this is how I plan on installing this driver side panel. So I've got it sitting on a crate on some rubber matting, and ideally I can just make my connections, prop the panel up and screw it straight into the frame. And to do this, I'm using a few connectors. So from that conduit T'd hinge, got the lighting circuit with those 8 cables going into this Deutsch DT connector. So from this other side, the DT connector, there's going to be a loom going onto the L bracket that I've made, and then through those slots to the corresponding channels on the TVMS. Same goes for the other side. We've got those 3 DTP connections we made. These are the corresponding DTP female connectors. Got a loom running up and onto the L bracket to the corresponding grommet. And of course, we can't forget the Anderson plug, the positive and negative, which will run to the Anderson plug right over there. So everything I've shown you so far in the video, all the method of the wiring should have covered what we need to do for this panel. So I'm gonna get straight into it. I'll be right back with you guys. All right, so it's been about a week and I've just been chipping away at this, getting it sorted. And I'm really happy with how it's turned out. So this panel is all sorted. All the wiring is done for the TVMS. I wanted to show you that the TVMS system comes with 2 of these temperature probes. So there are 2 temperature inputs that you can monitor temperatures on the Red Vision screen. So I'd like to collect some data on the temperature inside the canopy. So that's going to be this probe. And once I figure it out, I'd like to throw a probe inside the fridge to see how well it copes with the heat. So I will quickly show you guys the backside, the brains. Now, of course, it didn't follow my original plan. But once I laid the cabling on the panel, it was clear to me that this would work better. So I've got the thicker core cabling sitting on top of the L bracket and the rest of the accessory wiring underneath the L bracket. Just made more sense that way because if we were to do some troubleshooting, it makes the wiring a lot more accessible away from the core cables. Everything I've done here is nothing new to what I've already shown. Again, I've used fleece tape to help with abrasion, cable ties to secure the cabling nice and firmly onto the panel, so free from any vibration. I've got P-clamps there just to direct and I guess contour the cabling. Just helps guide the cables so you get less of an angle. And of course the CMS lead to the DPO. I've got the active, the earth and the neutral wired in. I'm happy with this panel, so I'm going to go and install this back into the canopy. And I believe once that's done, it's just a few cables from the battery to the panels, and we're going to be ready to fire this thing up. We're almost there, guys. All right, we are inside the canopy, getting ready to wire everything up to the battery. Now, with the normal canopy, it comes with this channel from the panel so that you can run your thick cabling all the way inside this battery compartment. So everything's kind of tucked up out of the way, and the cable's all supported by that channel. Now, before we go ahead and just wire everything straight to the battery, we really need to make sure we've got our connections right. And this is a very critical part of this whole 12-volt system. This is Redarc's battery sensor, also known as a smart shunt. And it also has a little temperature probe, which will allow you to monitor the temperature of the battery. So the way you wire this shunt will be the difference between an absolutely dysfunctional monitoring system to a system which will read current draw very accurately and give you a good idea on the state of charge of your battery. Now, the way shunts are designed to work is there is a bar which sits between these 2 panels, and it measures the voltage difference between these 2 terminals in real time. So it's able to give you a very accurate reading based on the resistance of that bar which sits between those 2 terminals. Now, the way you wire this is on the left side of the shunt, you can see it says ground. All the common grounds will go to this side of the terminal. So your inverter, your lights, all your accessories, the grounds will go to this terminal. Now, on the B-neg side of this shunt, the only thing which will connect to this terminal will be the cable from the negative terminal of the battery, nothing else. And that is the only way that this shunt can accurately read your current draw. So now I've got the battery sensor in. It's just a matter of connecting all our positives to the positive terminal of the battery, all our negative grounds to the common ground of the shunt, and one negative cable from this side of the shunt to the negative terminal of the battery. All right, so got all the cables wired in, and yeah, this is probably the neatest way I could have run it. I really didn't want to have this inverter cable like this, but you know, it was the best and shortest option for that very thick cable. So I'm okay with that. But the battery sensor over there too. And this is the 80 amp circuit breaker for the TVMS. So yeah, nice and close to the battery is the way you should have it. I'm not going to pretend I haven't already switched it on, so we are going to have a quick look. And that's the system firing up. I've had a quick play around with the Red Vision, but I really need to set those two screens together. But it's good to know that all the CAN bus devices are reading. So if you are not familiar with the CAN bus network on this Red Vision system, there needs to be a terminating resistor at some point in the circuit. So it kind of daisy chains, and there needs to be some sort of closure in that network. And that is all the wiring for the Canopy finished. And I'll be completely honest, it's taken me about a month and a half to get to this point. A lot of late nights, a lot of long hours wiring, and also filming. So if you want to support the channel, make sure you go and hit the subscribe button. But we are still not finished. What I'm going to do is spend probably a day just tidying everything up in the Canopy. There's a lot of mess at the moment. And then I'm going to go and double check, triple check all the connections, and then we can get on to configuring this whole Red Vision system. So I still got to put in the fuses. I've got to configure the switches, got to get the fridge back in, test the inverter out, and we should be all good to go. I'm not going to bore you with all that, so I will see you guys when it's all done. Okay, a few nights later, and the whole Canopy setup is complete. The 12-volt wiring is all sorted. There's absolutely nothing to do. The fit out's complete. It's ready to go back in 79, and we've just got a few wires to connect up to the car. And I'm extremely happy with how this has turned out. It's completely followed the plan I had for it. And yeah, I think I'd be happy to show you guys what I've done since the last clip. I've tidied up the Canopy, I've programmed the Red Vision system, and I've also done a bit of cable management. With the Red Vision system, it was extremely fiddly and tedious to program. So you got the Red Vision configurator app, which you use to program the display and also the outputs on the TVMS. For the crazy amount of money you pay for this gear, the app is actually quite substandard. And I know it's a few years old, but I just hope they would, make it a bit more user-friendly. So the biggest task was programming that second Red Vision display. So the standard setup comes with the Manager 30, TVMS, and one screen. By adding the second screen, you actually have to program it in the place of the first screen. So kind of tricking the system to believe that that's actually the original screen. And you do this in the CAN bus network we talked about. That we were daisy chaining all the devices so that it all links on the one CAN bus network, and you've terminated on both sides. With the second display, you actually have to disconnect the first original screen and have that second screen in the position on the CAN bus network which the first screen was originally on. I don't think that makes a lot of sense, but if you can imagine, you got two screens, one's on the other side of the Canopy. That screen, when you program it, needs to be in the network position of this first screen. So I got lucky in the sense that the way I wired this screen, I didn't actually have to pull this panel off, which would have been a big task. I grabbed a long RJ45 cable. I was able to disconnect the system from the Manager 30 and run the cable across to the other side, where it was a lot easier to get access to that second screen. Yeah, I thought I'd just mention that in case someone comes across this issue. But apart from that, it's all sorted. I'll quickly show you guys the screen. Okay, we're looking at the passenger side Red Vision display. It's programmed exactly the same as the driver's side, so the same layout, the same switches, the same functions. It's the same screen. And you've got 6 soft keys here. They call it soft keys instead of switches. And you can set it up with different switch menus, and I've got 2 set up. So I'll quickly run you through this main screen. So the first soft key menu is set up for things that I always use. So LED strips here. I've got all the USB ports on and off on this switch. I think we have like 8 USB ports in total. Got that big rear floodlight. The fridge, which is on at the moment, and the rear Anderson plug, which supplies light to the awning. This is the inverter remote, so turn it on and you can see the inverter switch on. Just give it a few seconds and then we'll have power at my power board here. So just flip it on and off. So easy. I love having the remote switch function on the inverter. So now going to the second soft key menu, go down there. So I've got all the power supplies on this this menu. Got the cigarette sockets, got the 2 Anderson plugs, the cabin switching, and of course the inverter as well. Looking into the middle of the screen, the time is 10:22. The temperature is 20 degrees Celsius, reading off that probe we set up earlier. The state of charge is 89% and currently drawing 11 amps discharge. If we were to discharge at the same rate constantly, this battery will last 22 hours, and that's with 0 amp charge from the Manager 30. So no solar, no AC input, and no input from the charger. So the second battery information screen is also pretty good. I think I'll be using this a lot. It'll show you the charge you get from the main battery. It'll show you the solar you've generated, as well as a few ways you can monitor the discharge and charge of your battery. So just some extra information. So yeah, I think this kind of setup, it's really nice to have. It really helps you effectively monitor your battery. Apart from the revision display, this afternoon we actually lifted this 130 litre Bushman fridge in there. And I've got it pushed all the way back to the wall. So I've got plenty of space here. And I've also modified the bracket to move the fridge over to the right a little bit. I just want to maximize my storage on this side. And perhaps I might put a little coffee machine here. I'm gonna put like a few Coronas there, some milk. Yeah, it's a neat little setup. So I am mindful, I am not the tallest guy. So when this canopy goes back into the car, I think I'll probably have to bring the fridge out a bit more. So it's just kind of hanging there at the moment. It's not bolted down yet. Let's move to the other side. And the driver's side, got the amber light going at the moment, bit of mood lighting. But let's change this back to a warm light. So yeah, same revision display, same function as what I've shown you on the other side. Now the TVMS, I've gone and made all these labels just to mark out exactly what circuit goes to what fuse. And I've also put in the amps there. So changing a fuse out is going to be very straightforward. I bought a box of these fuses off eBay. So I'm going to have plenty spare. I'll just keep this in the car. Apart from that, DPO on this side, with the inverter on, I've got power on and off on both of those outlets. I'm stoked how this has turned out. Now in the next few days, the weather is clearing up, so I'm going to push the canopy outside, I'm going to jack it up, put it back on the 79, and then we can complete the wiring then. I'll see you guys soon. Morning. So this morning we are hooking up the canopy wiring to the vehicle. So it's actually not much to do. So 2 connections, 4 wires, and we're just dealing with the charging side today. So there are 2 ways we will be DC charging the canopy setup. The first way is through the solar panel on the roof. I'll quickly show you guys. The solar panel is a 100 or 120 watt. I actually cannot remember. I will put it up on the screen. And that's been going to my battery box for the past almost 2 years. So this beast of a battery box, I actually did a video on this, but it's still going strong, supplying all the DC charge I need for most of my everyday needs. So that's been running very well, but we're upgrading now. And the primary source of charge is coming from the vehicle alternator. So let's start with the solar wiring because it's extremely easy. So with the solar wiring, we are just running 2 wires to the Manager 30. With most modern day chargers, they have built-in solar regulation. So in this case, I have an unregulated panel, 2 wires going straight to the Manager 30, and it will manage my solar input. Okay, so this is the solar wiring. Now, don't ask about the different color of the Anderson plugs because yellow is just what I had laying around 2 years ago, and red is the general standard when it comes to solar. So the yellow side is going to be going to the Anderson plug that I put on the roof rack over there, and the other side, the red Anderson plug, is going to be going onto the back wall of the canopy. If you remember, we did those 2 plugs. That one is for solar. Okay, so with the solar panel connected, we can immediately see some charge coming in. Now, it's a cloudy day, but we still have a bit of partial sun hitting the panel. It's only charging 1.4 amps at the moment, and 22 watts, you can see over there. So yes, it is a slightly cheaper panel. I've had it for 2 years, but I've actually seen it hit about 80 watts. So I will keep an eye on that, and if the panel needs to go, maybe we'll have to upgrade that one too. All right, just quickly, the sun has just come out and we are pumping 78 watts, 77 watts. And the last connection we're making is from this Anderson plug, so the Manager 30 charge side to the starter battery. So we are going to be using this 6BNS cable. Now, Redarc is quite clear the cable sizing you need depending on the length of cable you're running. So because people are mounting the chargers in different locations, depending on the length of cable, you can potentially get a bit of a voltage drop. So you don't want any resistance. The longer the length of the cable, the greater the resistance. You probably need to go up a size in the amount of copper strands. So we're going to be going with 6BNS as recommended by Redarc. All right, so just getting out of the sun. And yeah, so to make your life a bit easier, you can actually go ahead and buy a dual battery wiring kit for this part of the install. That usually includes some sort of fuse. I think usually they are inline fuses. You'll probably get a few Anderson plugs and about 5 meters of cable to the specification that you need. But we obviously have all those components here. We're going to make our own kit. So my plan is to install a MIDI fuse alongside with the compressor MIDI fuse and run the wiring the exact same way I did the compressor, alongside the chassis, above the chassis, along the brake lines and up the side of the tray to that Anderson plug. And of course, it's going to be a bit difficult to show you as I go, so I'm just going to do the install and I'll be right back with you guys. It was a really hot day today. So I'm actually filming this in the afternoon. Got it smashed out this morning, took me 3 hours to do. And I had kind of prepared the night before. So one of the requests I got in part 1 of this series was to show how I ran the wiring from the starter battery to the canopy. So I will show you guys that first. All right, we're gonna start back at the canopy here. So one of the good things about the Norway canopy is it's got a provision there for an Anderson plug. So I got that bolted down, and then that cable runs with the tray down to the chassis rail. You can see where the cable comes down and meets up with this conduit. So inside the conduit, I've got the compressor wiring and also the DC charge wiring. 2 6BNS twin core cables running inside this conduit on top of the chassis rail, all the way to the front where the rail is adjacent to the guard. From this point, the conduit shoots up behind the front passenger guard, not into the inner wheel well. We don't want the cable there. We're going behind the body mount, up into the guard, into the engine bay. So the cables run inside the guard and out right over here. Continues along with the stock harness underneath the fuel filter with the 2 MIDI fuses under there to our battery terminals, so the positive and negative side. Now everything is in securely, everything is gonna work, but it's not very tidy. And it's something I've wanted to do on this car once we've got a few more accessories in, because there's a lot going to the battery at the moment, the main starter battery. So I plan on making a separate video for this on how to declutter this start battery. Probably we'll have like a MIDI fuse panel here and a place to hold the fuses and the relays. So yeah, stay tuned for that. Hope that's made a bit of sense. At the moment, we are not really drawing anything from the solar panel, but earlier today I saw it hit 97 watts. So I'm happy that the solar panel is working somewhat efficiently. It's definitely enough for my setup. With the cable for the alternator wired in, let's start the car and see what this looks like. Okay, pretty much instantaneous. So we're up at 32.5 amps of charge. And with the green arrow going upwards, it means that the battery is charging, and it'll take 3 hours to complete that charge at the current rate of 32.4 amps. So yeah, everything's working. I'm so pleased with this. And that's it for the video. I hope you guys enjoyed that one. This was by far the longest video, the most difficult to film of any I've produced. The amount of detail I wanted to show, I wanted to provide that so that you guys can learn and perhaps do a setup like this as well. So if you want to support the channel, make sure you subscribe, leave us a like, and let me know what you think in the comment section. And if you have any questions at all about any of this stuff, let me know and I will try to get back to you. If you want to support the channel further, please go ahead and check out my new website. I've got some merch there. Now, in part 3 of this series, we're gonna head up bush and test this whole system. I wanna show you guys in depth everything about the 12-volt setup inside this Norwell Canopy, which I'm absolutely loving. I wanna do a rundown of the cost as well, so you guys have a realistic idea of how much it costs to do something like this. So I'll see you guys then. Stay tuned.